Ryan is building a matchstick sequence as shown below. How many matchsticks will he use for the nth figure if the pattern of adding two new squares horizontally and two vertically continues? Okay, so the formula for finding this sequence, it's an arithmetic sequence, which means it's going to be adding the same amount each time to get the next term. The formula for that is a sub n equals a sub 1 plus n minus 1 times d. Okay, a sub 1 is equal to the first term. Okay, the first term in our case is going to be the total number of matchsticks that we have in the first box. So on the first figure here. So we could say, we could just count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So a sub 1 is equal to 16. Okay, n is going to be our variable in this. We're going to leave it as n because it's asking us to find the nth term. So we need n to stay in there. So a sub n is the nth term, which involves n. Okay, so to find our d, d is equal to the common difference. Excuse me. Equals d. Okay, the common difference is what's the number that's being added each time to get the next term. Okay, so we know this one has 16. How many does this have? Well, let's just count the ones that we added to this one. So it looks like we've got 2 here, 1, 2, 3, 4, and it looks like we've got some up here, 5, 6, 7, 8, 9, 10. So it looks like we added 10. So the first one has 16. The second one has 26. And if we want to make sure, we don't really have to because it says that it continues. But the next one should have 36. Let's see what it added to the second figure. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one will be 36. So our common difference there is the number that we're adding each time, which is equal to 10. So to figure out the formula for the nth term, a sub n is equal to a sub 1, 16, plus n minus 1 times 10. So that's 16 plus 10n. I'm just distributing here. Okay, so 16 plus 10n minus 10. And then let's combine those two terms. And let's write it down here. So a sub n is equal to 10n plus 6. Now, if you are not completely sure if you got this right, well, just try the first three values and see if it works out and gives you 16, 26, and 36. So if you plug in a 1 here, 10 plus 6 is 16. That's the first one. If you plug in a 2 here, 10 times 2 is 20, plus 6 is 26. Likewise, 3, 30, plus 6, 36. So it works. Okay, I'm going to take this a step farther and do this in terms of not matchsticks. I'm going to do this in terms of boxes or squares, whatever you want to call them. Okay, so this is not part of this problem in what it asked, but I'm going to add this to it. So let's look at the first term in terms of how many squares we have. 1, 2, 3, 4, 5. Okay, so let's write this down. Squares this time instead of matchsticks. So our first term has, what do we say? 5. Okay, 5. The next term, 1, 2, 3, 4, 5, 6, 8, 9. And then 9, 10, 11, 12, 13. Dot, dot, dot. Okay, so 5, 9, 13. So what is the common difference there? What are we adding each time? Well, what is 9 minus 5? 4. What is 13 minus 9? 4. So our D, keep in mind that's our common difference, is 4. What's our first term? A sub 1. Well, that's equal to 5. So to figure out in terms of squares instead of matchsticks, which again the problem didn't ask, but we want to do a little extra. So we get A sub n is equal to 5 plus n minus 1 times the common difference of 4. is equal to 5 plus 4n minus 4. So a sub n is equal to 4n plus 1 for the squares, not the matchsticks. So let's try it and see if it works. The first one should give us 5 if we plug in a 1. It does. 4 plus 1 is 5. If we plug in a 2, we should get a 9. 4 times 2 is 8, plus 1 is 9. If we plug in a 3, we should get a 13. 4 times 3 is 12, plus 1 is 13. So it works. So our formula to find the nth term in terms of squares is 4n plus 1. Our formula to find the nth term in terms of matchsticks is 10n plus 6.